Welcome back to RamZland. I'm so glad that you could be here today. Way to graph a linear function. And some of these samples are very simple. And I'm hoping that after doing several of these, that it'll become easier for you to graph linear functions as well. So I want to start out by looking at this first sample here, where it says you're using slope, and it'll explain to you what each part of the function for slope-intercept is. So first of all, when you look at y equals mx plus b, m is usually written as a fraction. So if you just have like 1 over 2 x plus b, the top number tells you whether to go up or down on the y-axis, and the bottom number tells you to go to the right on the x-axis. So if you had y equals 1/2 x plus b, what 1/2 would mean is go up 1, and the 2 would mean to go to the right 2 spaces, okay? So on this function right here, you have y equals mx plus b. On the b is where it intersects y. So this is on the y-axis, okay? So you'd start here, and then m would tell you how far to go up and how far to go over, okay? So for this one, if there's no number in front of x, you're assuming it's just 1. So this would mean go up 1, over 1, up 1, over 1 to graph that function. Let's look at another example down here where it's a little bit easier. Okay, so if the slope is 0, that's the one that we explained. Let's take a look at your coordinate plane. Let's say I have the function y equals, let's say, 2 of x plus 3. So right here, this tells you where it starts on y. Okay, so remember, positive 3 means you go up on y. So this is where your line would start, okay? If there's just a whole number in front of x for the slope, it's always over 1, because you know every whole number is over 1. So this means up 2 and over 1. So this is up. And if the numerator is negative, then you go down. And then this bottom number is over. They call that a rise over run. Rise meaning up or down, run meaning side to side. So from your intercept, from your y-intercept 3, I would go up 2, 1, 2, and I would go over 1 and put a dot there. And if you want to continue the line, you'd go from this dot up 2, over 1. So graphing that linear function just means to connect those dots. Linear means line, so it should make a straight line, okay? So that is the graphed line of this linear function. Let's do another one. Let's say I have y equals, let's have one that goes down. How about -2 over 3x, and let's say plus 1. So the last number here is called the y-intercept, because that's where it intersects y. So that's 1. So here's positive 1. That's where it would start. Now, if you look at the slope here, this time it's negative. So instead of going up, I'm going to go down 2, and then this is the bottom number. The denominator tells you to go over to the right, over 3. So for here, I'd go down 1, 2, and I'd go over 3. 1, 2, 3. And if I wanted to make another dot, I would, again, do the slope again. From here, I'd go down 2, 1, 2, and over 3. 1, 2, 3. And then if I wanted to graph that line, I would just simply connect those dots. And it would look like that. Okay, let's look back at our tutorial here. Okay, so if you look at this example here, they have a case where there is no y-intercept, and this is really important. There's no slope. So if you just have x equals a, and let's say x equaled 3, then you just find 3 on the x-axis. There's no slope, so this is just a vertical line. It just goes straight up and down. Sometimes you'll have that. Let's sketch this one. Okay, so it says y equals 2x plus 1. Remember, if the slope is a whole number, it's over 1. So this literally means, since it's positive, means up 2. And this 1 here means over 1. This 1 right here is on y. Okay, so if I graph this, here's my coordinate plane. The first thing I want you to do is find positive 1 on the y-axis. Remember, y is vertical and x is horizontal. So if the intersection is 0, 0, I'd go up 1 on y. That's where this linear, this function would start, this linear function. Then the slope is 2, so that means up 2 from where I started and over 1. And then all you have to do is just connect your two dots. And you graph that line, okay? So 1 is the y-intercept, 2 over 1, that's the slope, okay? Let's look at another example. Okay, now, sometimes they'll give you a function and they'll say, find the slope. That's the part in front of x. That's called a change in y over a change in x, okay? So when you find the slope, you have to make sure that you're subtracting the same y from the same y on both sides. So let's say I had 2 points. Let's say I had 3, 1, and I had 2 and 4, okay? I know my first number is x and my second number is y for each of these, okay? But I can't mix them up. So for a change in y over a change in x, I have to subtract y minus y and x minus x to find the slope. But I can't do it the other way. So like if I did, let's say this is y2 and this is y1, this is x2 and this is x1. So if I subtract 4 minus 1, that's y2 minus y1. I can't do that over x1 minus x2. It has to be the same direction. So if I'm subtracting this way, 4 minus 1 on top, then on the bottom I would have to do x2 minus x1, 2 minus 3. So this would be 3 over negative 1. So you have to make sure that when you find slope, you're doing it in the same way. You see where it says these two are correct, y2 minus y1 over x2 minus x1. And then over here, y1, x1, y2, x2. And over here, they switched around, y2 over x1, you can't do that. y1 over x2, you can't do that. So it has to be 1, 1, 2, 2, or 2, 2, 1, 1, okay? And that's for finding the slope, okay? Let's see if they have another example of that. Right here, so here's your first set of numbers, here's your second point, okay? So this would be like x1, y1. This would be x2, y2. So you can see that they're going from y2 to y1. Here's y2 minus y1, and here's x2, 5, x2 minus x1. So your slope would be 3 over 2, okay? And we'll look at some examples of that. Let's take a look at graphing a few lines first, okay? So in these examples, they just want you to identify the slope and the y-intercept, okay? So y-intercept is simply where it crosses y. So for this first number, it's crossing y at 1. So I'd say y equals something plus 1. So m of x, m is the slope. So from 1, it looks like it goes up 1, 2, and it goes over 1. So it goes up 2, that's the numerator, and it goes over 1. So you could say for this one, y equals 2x plus 1. 1 is the y-intercept, and 2, or 2 over 1, is the slope. Let's look at number 2, okay? Y equals, where does it intersect y? It looks like it intersects y right here at positive 1. I think that's 0, yeah, positive 1. So something plus 1. Let's find out what the slope is. So from y, it goes up 1, 2, and it goes over 1, 2, 3. So that looks like 2 over 3x plus 1. So the slope is 2/3. The y-intercept would be 1. Let's look at number 3. Where does it intersect y? This one intersects y at 2, it looks like. Okay, so I'm going to have y equals something plus 2. Let's look at the slope. So from this 2 right here, it goes down 1 and it goes over 2. So if it goes down from y and you're looking to the right, it goes down, that means it's negative. So this would be -1 over, and it goes over 1, 2. So -1/2 of x plus 2. Y-intercept is 2, the slope would be -1/2. Let's look at number 4. Now number 4 is tricky because it looks like there it is, -1. So y is going to equal something of x minus 1, okay? Now from where it intersects y, it looks like it's going up 1 and over 2. So up 1 is +1 over 2, 1/2 of x minus 1. So your y-intercept is -1 and your slope is 1/2. This part just has you just identify the difference between slope and y-intercept. So slope is what comes in front of x. So the slope for this one is 3, or you could think of 3 over 1. So that would mean up 3 over 1. And the y-intercept, where the line starts, is 4, that last number. Okay, y equals -2x. So the slope is -2 or -2 over 1. So that means from where you start on y, you're going down 2 over 1. And then where you start on y is 8. That's the y-intercept, this last number, okay? Okay, so this one says y equals 1/2 of x, and there's no intercept. So this would start at 0, right in the center of your coordinate plane. And then your slope is 1/2. So from 0, the very center of a coordinate plane, you go up 1 over 2 for your slope. This one looks like your y-intercept, this last number is -1. And then your slope is -3/4. So from -1, you go down 3 because it's negative, and then you count over 4 to place another dot on your graph. Okay, these graphs are kind of small, so I think I'm going to zoom in on some of these. You see this a little bit better? Let's make that, can make that even bigger. Okay, so let's take a look at number 9. Now notice there's nothing in front of x. So if you just see x by itself, I want you to think there's always a 1 there. Okay, so this is like 1 over 1 for both of these because you don't see anything there. Okay, the y-intercept is always that last number, so it's +5. So I count up 1, 2, 3, 4, 5. That's where I'm going to start my line. And the slope is 1. So that means up 1 over 1. Up 1 over 1. And then to graph this linear function, you just connect the dots. And that's it. Let's look at number 10. This one, the y-intercept is -7. So here's 0, and I count down 1, 2, 3, 4, 5, 6, 7. And there's nothing in front of x, so there's a 1 there, 1 over 1. So I go up 1 over 1, up and over, and then to graph it, I just connect those dots. That's all you have to do. Let's look at number 11. Let me scroll over a little bit. Okay, here's number 11. So the last number is on y, and it's +1. So I go up to 1. And then the slope is, it just says -4. It's always over 1. So if there's nothing there for the denominator, just write a 1 there. Remember, if it's negative, you're going down. So you go down 4 and then to the right 1 from where you start. So 1, 2, 3, 4, and then go over 1. And then from that spot, if you want to make another dot, go down 4, 1, 2, 3, 4, and then over 1. And then to graph this linear function, you just connect those dots. Let's take a look at number 12 here. Okay, so for number 12, it just says y equals 2x. So if there's no y-intercept, you just start at 0.
0.
And if it's a whole number, it's always over 1. So this would mean from 0, I go up to over 1. Up to over 1. And then just connect them. Like that. Okay, let's look at number 14. Let me scroll over here. Oh, there's another one over here. Let's look at 13. Okay, so again, your last number is on y, and it's 2, positive 2. So I go up to 2, and I put a dot there. Then my next, my slope is 1 over 3. So that's up 1 over 3. So I go up 1. I count to this right. 1, 2, 3. Up 1 to the right. 1, 2, 3. And I graph it by connecting those points. And that's it. Let's take a look at number 14. So this is y. That's where you start your line, positive 3. 1, 2, 3. That's where you start. And then my slope is negative 1 over 4. So instead of going up 1, I'm going to go down. Down 1 to the right 4. 1, 2, 3, 4. And this is a really gradual slope. Down 1, 1, 2, 3, 4. So remember, your slope is just simply a non-vertical line. So for it to be a slope, it's not straight up or down. It's always slanted, okay? Going up or slanted going down from y. Okay, here's number 15. Looks like y is negative 1, so that's below. So I go down 1. That's where my line starts. And then your slope is 2 over 3. So this is a rise over run. This is up 2, and this is over 3 from here. So I go up 1, 2. I go over 1, 2, 3. Up 2 over 1, 2, 3. And then I just connect those to graph it like that. Let's take a look at number 16. So this time y looks like it's negative 3. So I go down 1, 2, 3. That's where you're going to start. And then your slope is negative 3/4. That means I have to count down 3 and over 4. So 1, 2, 3, and over 1, 2, 3, 4. And then to graph that linear function, just connect your dots after you plot them. Better than I did. Okay, now, this next part, they want you to figure out what the slope is. So remember, slope is a change in y over a change in x. And the only thing that's tricky about this is that you make sure you're subtracting the same direction, okay? So if I'm going to subtract, let's call this y2. If I'm going to subtract y2 from y1, then I have to subtract x2 from x1. I can't go the other way. I can't subtract y2 from y1 and then subtract x1 from x2, okay? So let's see what that would look like. This is what the slope is going to be, okay? So I have y2, negative 5 minus 5. Okay, that's y2 minus y1. So I have to go the same direction from here over to here. So I have negative 3, that's x2, minus 3. So what's that going to be? Well, negative 5 minus 5 is negative 10.
10, 6.
Negative 3 minus 3 is negative 6. So my slope is going to be negative 10 over negative 6. Let's take a look at my next one. Let's call this x1 and y1, x2 and y2. So I have to have a change in y. Change means to subtract over a change in x. So let's have y2 minus y1. That looks like 9 minus 3 over x2 minus x1. So here's x2 is negative
Negative.
minus negative 5.
Negative.
Now you can see how we have two minus signs here. So two negatives will be a positive. So this would be like negative 4 plus 5. So I know 9 minus 3 is going to be 6.
Negative 1.
Negative 4 plus 5 is going to be 1. So for this one, my slope is 6 over 1, or simply 6. Okay? Let's look at a few more for finding slope. Okay. So this is x1, y1, x2, y2. So change in y, this is the rise over change in x. So I have 3 minus 4, and that's going to be over 2 minus 2. So I know 3 minus 4 is negative 1 over 0. I'm going to say negative 1 is going to be my slope for that one. Let's look at part D here. I have y1 and x1, and I have y2 over x2. So I'm going to have negative 7 minus negative 7 over 5 minus 10. So I have two negatives here. So this would be like negative 7 plus 7. That's 0. And I have 5 minus 10. That's going to be negative 5. So again, if you have a 0 here in your, well, yeah, this should be 0. If you have 0 in your slope here, the whole thing is going to be 0 for your slope. Let's take a look at another example up here. Let me go back to some slopes. Okay, so sometimes in slope, they'll have it written as a rise over run. And rise just means y1 minus y2 over x1 minus x2. Just exactly what we were doing. I'm going to zoom in on this just a little bit so you can see it better. Okay, so if I plot these points, 0, 2, I'm going to say this is x and this is y, x, y. If I plot 0, 2, what does that look like on my coordinate system? Here's 0, and for y, I go up to 1, 2. Okay? Here's my second point, 4 and 3. So I go over 4 on x, 1, 2, 3, 4, and I go up 3, 1, 2, 3. Okay. So those are my 2 points, and I'm going to connect them. There's my line. Now, it wants you to find the slope, okay? So I can just look at this. I know that I'm going up 1, and I'm going over 1, 2, 3, 4. So I'm just looking at this. My slope should be positive 1/4. Up 1 over 4. I can see that. But if I wasn't graphing it, how could I just do it mathematically? Well, I would have a change in y over a change in x. So this is y2, y1, x2, x1. So that'd be 3 minus 2 over 4 minus 0. So 3 minus 2 is 1. 4 minus 0 is 4. 1/4. Let's look at my graph. Did I do that right? I go up 1 over 1, 2, 3, 4. You can see right there the slope is 1/4. Up 1 over 4. But I figured out mathematically by just doing a change in y over a change in x. Let's look at another one where you can kind of see how this plays out. Okay. I think this one, yeah. Okay, let's look at this one. So I have, this is x1, y1, x2, y2. So I'm going to have, let's see, 1, y2 minus y1, 1 minus negative 3 over 2 minus 0. So I have 2 negatives here. So 2 negatives equal positive. So 1 plus 3 is 4. 2 minus 0 is 2. So that looks like up 4 over 2. Let's try that out. So I have 0, negative 3. So here's 0, and I go down 3. 1, 2, 3. There's my first point. And I have positive 2, positive 1. So I go over 2 and up 1. 1, 2, and up 1. So let's connect these points and see if our slope is correct. Okay? So we said our slope was 4 over 2. So that's up 4, and that's over 2. So from this point to this point, I go up 1, 2, 3, 4. And I go over 1, 2. So that's up 4, and over 2. That's a rise over run, and you can see it right there in the graph. So that's why they do this. So here's x and y, x and y. So I'm going to do y2 minus y1. That's 4 minus, and it's a negative 1. Negative 1. Over x would be 1 minus 0. So 4 minus a minus is plus. So 4
5.
plus 1 is 5 over 1, or just the slope is 5. Okay. Do I have a graph for that one? Am I running out of graphs? Let's use this graph for this next one. Okay, so 0, 3, 4, and 1. So this is x1, y1, x2, and y2. Okay, so I'm going to have y2 minus y1. That would look like 1 minus 3. Over x2 minus x1 would look like 4 minus 0. So 1 minus 3 is negative 2. 4 minus 0 is 4. So I'm going to plot these points over here, and I'm going to see if my line goes down 2 and over 4, because that's my slope. So I'm going to plot 0, 3. So that means I don't go side to side. I just go up 3. 1, 2, 3. That's my first point right here. And my next point is over 4 and up 1. So over 4 on x, 1, 2, 3, 4, and up 1. Okay, so I'm going to connect these dots. You can see my line is going down, and my slope is negative. So I'm supposed to go down 2 and over 4. Let's see if it did that. From here, 1, 2, and then over 4. 1, 2, 3, 4. So it looks like it's right. Down 2 and over 4. And you can see that right in that graph right there. Let's do number 5. So this is x1, y1, x2, y2. So a change in y means y2 minus y2 minus y1 over x2 minus x1 for my slope. So that would mean negative 3 minus 1. And that would be 1 minus 0. Negative 3 minus 1 is negative 4. 1 minus 0 is 1. So that means your slope should go down 4 and over 1 if I connect these 2 points on a graph. Let's take a look. I think we have time for a couple more. Okay, let's try to graph this one over here. Okay, so this is x1, y1, x2, y2. So I have 2 minus, looks like negative 2, over 1 minus 0. Okay, so my slope is going to be 2 minus a negative is like saying 2 plus 2 is 4 over 1, or just 4. So the slope should look like you're going up 4 over 1 when I connect these 2 points on a coordinate system. So my first point is 0, negative 2. So I don't go side to side. Here I'm at 0. I go down 2. 1, 2. That's that first point. My second point is 1, 2. So from here, I go over 1, up 2. And then I connect these 2 points. Okay, and from this point, I should go up 4 over 1. Remember, this is rise over 1. Up and over. So from here, I go up 1 2, 3, 4,
Oh,
and I go over 1.
1.
So I'm seeing up 4 and
Over 1.
over 1, or simply 4 over 1 for my slope. Okay?
Yes.
Okay. So let's review some of the things that we looked at. So good to see all of you here today. What we went over today was slope-intercept form. And slope-intercept is simply an equation to help you graph a line. Whenever you graph a linear function, remember the word linear means line. If you graph it and when you connect the dots, it's not making a straight line, then something went wrong, okay? The second thing that we went over is when you just look at 2 points and it says, what's the slope? You're subtracting y over x. y2 minus y1 over x2 minus x1. And that's to find the slope. Remember, slope is a non-vertical line. So either it's going diagonally up or it's going diagonally down from wherever the line starts on y. So whenever you look at a slope-intercept function, the last number is where it intersects the y-axis. That's the vertical axis. That's where the line begins, okay? I'm going to post this on our channel. Some of you, maybe you haven't seen our channel, and I kind of want to make sure that
I think I got to see one last
see
week
that.
when I talked to you.
I need to see if I can share that with you. If I
What is
have
it
that
exactly
open. No,
under?
it doesn't look like. I guess I don't have that open. I thought I did. No, I don't have that open right now. But if you get on, if you just simply get on YouTube and type Keith Ramsey or Mr. Ramsey, you'll see a whole bunch of math videos. And those math videos are, you guys are in all of them. So if you find Keith Ramsey on YouTube, there's one channel that's just science videos. There's one channel that's just math videos. And I've got there's about 30 math lessons on there so far just from this quarantine. And I'm going to leave those up there and you can always go back and check. Also, one other thing is Wednesday is our last lesson for this school year. And then we'll have 3 weeks off and then we'll start up again. I'll still be Monday, Wednesday night, same format, just like this. And I think that we'll be meeting on Zoom like this probably until that last week in July. I do kind of think that Wayne is going to go back that last week in July. But you're going to have to wait for that. Okay. Now, if any of you have any questions, I think some of you, did you have a question? If you have any questions, make sure you're off mute. Some of you, I think you're still,
Am I on?
yeah, I'm trying to unmute you. I can't quite hear you, dear. I can see your mouth moving, but I can't hear you. But anyway, you can also text me too. But so I'll see you on Wednesday, same time, 5 o'clock, and I'll send you just a little reminder of that. Okay?
Teacher.
So,
thank you, teacher. Bye-bye.
Bye-bye. Until I see you again.
Careful. God bless you.
Bye-bye.
Bye-bye.